today we're going to look at how to solve problems with tree diagrams. Okay, we've got this problem to start with. I drive through two sets of traffic lights on the way to work. The probability that it is green is 0.6. What is the probability that both are green? What is the probability that one is green and one is red? What is the probability that at least one light is red? Okay, so we first of all draw out the tree diagram. Okay, so this is the first set of lights, so we can have either red or green. And then this is the second set of lights, we can have red or green, or red and green. So there's four different types of outcomes. We can have red and green and red, or green and green. Those are the four different outcomes. What's missing on here is our probabilities. It was 0.6 that the lights were green. So green will be 0.6, and of course we need to add up to 1, so red is 0.4. This, because they're the same, is repeated on the second set. It doesn't always follow that the second set has exactly the same probabilities, it's just because we're talking about the same things. Now this first question, probability that both are red, well, let's have a look at the roots through. If they're both red, this first one has to be red, and so does the second one. Just a reminder, of course, when we go along the tree diagrams, we times, and when we go down the tree diagrams, we plus. So to work out the red, and then the red, I do 0.4 from here, times 0.4 from there, and that is 0.16. So I get the answer 0.16. So both red, 0.16. One red, one green. Okay? So the first light could be red, but then the second light has to be green. One red, one green. Or the first light could be green, and the second light has to be red, because we've got one red, one green. So there are two different routes through the tree diagram that will get us the same result. Again, we times going through, so this is 0.4 times 0.6, which is 0.24. And this is 0.6 times 0.4, which is 0.24. We have two different outcomes that will help us out. And as I said, we add going down. So we're going to do 0.24, add 0.24, we add going down, which gives us 0.48. So the probability of one red, one green, 0.48. The last question says at least one red. Now, at least one red means that both of them could be red. That we could have one red and then a green, or that we can have a green and then a red. All three of those routes have at least one red, and sometimes two. The only one that wouldn't work is if we went green, then green, because none of those are red. Now thankfully, and which is why we put it at the end, we've already worked out all three probabilities for those three routes. Any of them can happen, so we plus going down. So to work this one out, I would do 0.16 plus 0.24 plus 0, let's put a plus in there, plus 0.24. 0.24 plus 0.24 is 0.48, plus 0.16 is 0.54, 0.64. So the answer is 0.64. So all times we've got to think about how many routes would take us through the tree diagram. We times numbers going along, and we add numbers going down.